Hello, geometry students. This is Miss Mackey. I am out today on Wednesday, November 20th. So this is what I would have told you had I been in class today. We're learning about the next two letters in our acronym. And, well, it's three letters, R bringing in, which stands for angle, bisector, and incenter. So let me get this pulled up here, and you will have these notes. Okay, so the angle, bisector, and incenter relationship in triangles. So, as you know, we've learned about angle bisectors. It divides the angle of a triangle into two equal parts. So there are three angle bisectors in a triangle. Okay, where those three angle bisectors come together and intersect is called the incenter. So I'm going to switch over to a picture, and then I'm going to come back to this. So here is the incenter of this triangle. This angle A is being bisected, angle B is being bisected, and angle C is being bisected. And where they all come together right here is the incenter. So I'm going to come back to this problem in a minute. Here's another picture, though, of the incenter, like this. It's the one we briefly discussed last week, and then I kind of changed the way we were going to learn it. So the incenter makes a circle around that point in the middle, and it touches the sides of the triangle at one point. So another way to think of this is the largest possible circle that you can fit inside of a triangle. So that's what this is going to tell us, but let's look at this real quick. So as we said, it's where the bisectors of the angles intersect. The definition is the point of intersection of all three interior angle bisectors of the triangle. The point that makes the incenter is equal distances from all three sides of the triangle. So it's also known as the center of a triangle circle, since the largest circle could fit inside the triangle at the incenter. So when you inscribe the circle around that point, it's called the incircle. So here is a picture. Here's properties of an incenter. So here's another picture. So if this is the incenter of the triangle, then the line segments A and E and A and G are congruent to each other, so they would be equal. The line segments CG and CF are congruent to each other, and BF and BE are congruent to each other. And then it tells us how to prove that right here. So thankfully, you don't have to worry about that. But we are going to go back to this in just a second. I'm going to go back to my notes for a minute, and then we're going to come back to this. So let's switch back over here. And again, you have copies of this, so you can use that as needed. We already talked about the definition and the properties. So consider a triangle ABC with the measurements of 60 at one angle, 70 at the second angle, and 50 at the third angle. So obviously when you add all of those together, it comes up to 180 because all triangles have a measure of 180 degrees total. So the angle bisector of angle A will divide that one into 30 degrees each, because 60 divided by 2 is 30. The incenter will be located at the intersection of the angles of A, B, and C. So in your notes, you can look at these analogies and see how you can see it kind of in regular life. I want to point out some misconceptions about the incenter. So these are things that are not true. So it says some students might think that the incenter can be located outside of the triangle, but in reality, the incenter is always located inside the triangle, whether it's an acute, right, or obtuse triangle. Relationship with triangle sides. Students may believe that the incenter is the midpoint of a triangle's side or that it has a special relationship to the triangle's vertices. But the incenter is the intersection point of the angle bisectors, not related directly to the midpoints of the sides. We learned yesterday the midpoints of the sides, that line that intersects and makes midpoint in the sides, is the median. Some students might assume that the incenter is equidistant from the triangle's vertices. However, the incenter is equidistant from the sides of the triangle, not the vertices. Understanding the incircle. Students may misunderstand that the incircle, which is centered at the incenter, does not always perfectly fit within the triangle in a way that appears visually symmetric. The size of the incircle depends on the triangle's angles and side lengths. It goes on to say about confusing it with other centers, but y'all aren't going to confuse it because we've learned them day by day. The angle bisector theorem misapplication, we're not worried about that right now. And students might incorrectly believe that the incenter creates angles of equal measure within the triangle. While the angle bisectors create equal angles at each vertex because they bisect. Bisect means split it equally in half. So the angle bisectors are going to create equal angles at each vertex. But the angles formed at the incenter with respect to the sides are not necessarily equal. Okay, so those are just some common misconceptions. Okay, let's scroll down. I thought I had some more about the real world applications, but I guess I do not. But one thing I saw that I will just point out is that you can think of the incenter as being the place where you've got equal distance to the sides of something. So think of a basketball court and you do the tip-off right in that center circle, right? That will be the incenter of the court. Even though a basketball court is not a triangle, it's a rectangle. That incenter needs to be equally distant from both ends of the court to make it fair for both teams. And so the incenter, that center circle inside where you're going to do your tip-off, is going to be the incenter of the basketball court. Okay, let's go back over here to this picture. Okay, so let's look at this triangle. If I is the incenter of the triangle, then find the value of x in the figure. So let's do this together. If angle A is bisected and one part of it is 37, well, then the other part of it is going to be 37. If angle B is bisected and one part, sorry.
Can I get Alexis with your things to the office, please? Thank you.
If angle B is bisected and one part is 20, then the other part will be 20. And then if angle C has a value of x and it's asking you to find x, well, we're going to take 37 plus 37, and that gives us 74. So angle A, the total would be 74. And we'll take angle B, 20 plus 20 is 40. So that will give us the total of angle B. 40 plus 74 is 114. So then we take 180, because that's the total of all of the degrees in any triangle. We'll take 180 minus 114, which is the total of 40 and 74 added together, and we get 66. So if we have angle C's total at 66, but we need x, that degrees would be 33, because 66 divided by 2 is 33. So we can see right here how they did that. They added them up and divided by 2. 37 and 20. They did it a little bit different than I did, but we came out with the same answer. x would equal 33. Okay, so that is the basics of Incenter using angle bisector. So remember the acronym, all of, which is altitude and orthocenter, my children, median, and centroid are bringing in. So angle bisector and Incenter go together. And so today we're doing that part of the acronym, are bringing in. So now I've printed this off for you. You have a worksheet understanding the Incenter and angle bisector. There's a word bank. So you'll see the word bank right here. So you just fill in the blanks. And then there's some multiple choice questions. Very easy. But I just need to make sure you listen to this video and understand what you're doing today. Because tomorrow we'll be doing the last part, peanut butter cookies, which is perpendicular bisector and circumcenter. And then that will be all of our points of concurrency, and we'll be ready for our test on Friday. So thank you for your hard work. And let me figure out how to turn this off. And we will be done here. And do the worksheet. Do the points of concurrency assignment on Carnegie. And then make sure you turn in your homework from yesterday, which is the median worksheet front and back that we started in class yesterday. Okay, thanks guys. Have a great day.